बिस्मिल्लाहिर्रहमानिर्रहीम रब्बिश इश्रह ली सदरी वयस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली. Assalamu alaikum. Today we will do conceptual example 2.5, graphical relationship between x, vx and ax from the book Physics for Scientists and Engineers with Modern Physics by Serway and Jewett, 10th edition. The position of an object moves along the x-axis with time as in figure 2.8a. Graph the velocity versus time and the acceleration versus time for the object. The velocity at any instant is the slope of the tangent to the xt graph at that instant. Between t is equal to 0 and t is equal to ta, the slope of the xt graph increases uniformly, so the velocity increases linearly as shown in figure 2.8b. As we can see in figure 2.8a position time graph that between 0 and ta, the slope increases uniformly. Therefore, the velocity time graph shows a linear relationship between the points 0 and ta. Between ta and tb, the slope of the xt graph is constant, so the velocity remains constant. As we can see in figure 2.8a position time graph that the slope between the point ta and tb is constant. Therefore, figure 2.8b shows that the velocity time graph that between the points ta and tb the velocity is constant. Between tb and td, the slope of the xt graph decreases, so the value of the velocity in the vxt graph decreases. At td, the slope of the xt graph is 0, so the velocity is 0 at that instant. If we look at figure 2.8a position time graph, we observe that between the points tb and td, the slope decreases and the slope is 0 at the point td. If we look at the velocity time graph, figure 2.8b, we see that from tb to td, the velocity decreases and is 0 at the point td. Between td and te, the slope of the xt graph and therefore the velocity are negative and decreases uniformly in this interval. In figure 2.8a, between the points td and te, we notice that the slope is negative and decreases uniformly. Therefore, in figure 2.8b, we see in velocity time graph that the velocity is negative and it decreases uniformly. In the time interval te to tf, the slope of the xt graph is still negative and at tf it goes to 0. Finally, after tf, the slope of the xt graph is 0, meaning the object is at rest for t greater than tf. In figure 2.8a position time graph between the points te and tf, the slope is still negative. However, it becomes less negative with time. After the point tf, the position time graph shows that the position remains constant. Therefore, this shows that the velocity is 0 because the slope is 0 of the position time graph and the object is at rest. To summarize, the slope of the position time graphs gives us the value of the velocity. The acceleration at any instant is the slope of the tangent to the vxt graph at that instant. The graph of acceleration versus time for this object is shown in figure 2.8c. The acceleration is constant and positive between 0 and ta, where the slope of the vxt graph is positive. In figure 2.8b velocity time graph, we observe that the slope is constant and positive. Therefore, figure 2.8c, which is the acceleration time graph, shows a positive and a constant value of acceleration. It is 0 between ta and tb and for t greater than tf because the slope of the vxt graph is 0 at these times. If we look at figure 2.8b velocity time graph, we see that between the points ta and tb the slope is 0 and for points greater than tf the slope is 0. Therefore, the acceleration time graph in figure 2.8c shows that the acceleration is 0 between the points ta and tb and for the points greater than tf. It is negative between TB and TE because the slope of the VXT graph is negative during this interval. If we look at figure 2.8b velocity time graph, we notice that between the points TB and TE, the slope is negative and is constant. Therefore, the acceleration time graph in figure 2.8c show that between the point TB and TE, acceleration is negative and is constant. Between TE and TF, the acceleration is positive like it is between 0 and TA, but higher in value because the slope of the VXT graph is steeper. If we look at figure 2.8b velocity time graph, we notice that between the points TE and TF, the slope is positive and constant. If we compare it to the slope between 0 and TA, we notice that the slope between TE and TF is much more steeper. If we plot the acceleration time graph as in 2.8c, we see that the acceleration is positive and constant between the points TE and TF, and it is higher in value than the acceleration between the points 0 and TA. Notice that sudden changes in acceleration shown in figure 2.8c are unphysical. Such instantaneous changes cannot occur in reality. Figure 2.8 Conceptual Example 2.5 Part A Position Time Graph for an object moving along the x-axis. Part B The velocity time graph for the object is obtained by measuring the slope of the position time graph at each instant. Part C The acceleration time graph for the object is obtained by measuring the slope of the velocity time graph at each instant. May Allah bless us all. Thank you for watching. Allah Hafiz.